Okay, this lesson on polynomials looks at dividing, doing long division polynomials and synthetic division. It's a way for us to factor a polynomial. So, determine whether each binomial is a factor of it. So what that means is if you plug in -4 in for x and you get the remainder is equal, or if you get, not the remainder, sorry, if you get this equal to 0, we know that it's a factor. So if I plug in -4 and it equals 0, then I know it's a factor, it's a solution, it's x-intercept. So I'm going to go in and plug in -4, 3, -6 into this function, and -2 into this function. Okay, so to see if it was a factor, what I did was I plugged in -4 for x, and I tried to get it, and I saw if it was 0. This one was no, this one was yes, this one was no, and this one was no. So the only factor that we have so far in this group is x minus 3. We know that we could divide this polynomial by x minus 3 and not get a remainder. So if something is a factor, then the remainder is 0. We know that in math, if we divide 24 by 6, we get 4 and we don't get a remainder. So that means that 6 is a factor of 24. So we'll go back to long division right here. So I'm going to divide x squared plus 2x minus 30 by x minus 5. So I'm going to write x minus 5 right here, x squared plus 2x minus 30. First thing I want to do is do x times something equals x squared. Well, that's going to be an x. So I'm going to write that above my linear term. Now I'm going to multiply this x by x minus 5. So I write x squared minus 5x. Now remember, when you do long division, you subtract these. So x squared minus x squared cancels out. Now I have 2x minus a -5x, which is 7x. Bring down the -30. Now you're going to see x times what is 7x. Well, that's 7, so I write plus 7 above the constant term. Now I'm going to multiply x, 7 times x, and 7 times -5. So I have 7x minus 35. Then I subtract them. These cancel out, so -30 minus -35 is positive 5. This is my remainder. So this means that this is not a factor because I have a remainder. Okay, now I'm going to do a different one, long division. I'm going to write x minus 5 right here. Write 9x cubed minus 48x squared. I don't have a linear term, so I'm going to write plus 0x just to hold that in place, plus 3. So the top is going to be 9x squared, and I'm going to multiply that. So it's going to be 9x cubed minus 45x squared. Subtract, cancel. Add -48 plus 45 because you have two negatives, so it's going to be 3x squared plus 0x. So what do you multiply x by to get 3x squared? Well, you multiply it by 3x. So I'm going to have 3x squared minus 15x. Subtract. These cancel out. Now you have 0x minus -15x, which changes to 15x. Bring down the 3. So x times what is 15x? It's 15, so I write plus 15. And now I'm going to multiply x times 15x, 15x. 15 times -3 is -45. So no, it's not a factor because you end up with a remainder of 48. So just make sure that you hold a spot for it if it skips a degree in the polynomial. So synthetic division is a way that you can divide. So I'm going to set these up first with synthetic division. Okay, so to set this synthetic division up, what you do is you make kind of a long L, and then if x minus 5 is a factor you're checking to see, or you're dividing it, you're going to put 5 on the outside. So look at the pattern with 2, negative 3, 3. Then you line up all of your coefficients across. 1, negative 8, 17, negative 10. And you're going to put a 0 if you skip a degree. I did not have one that skipped a degree, so I didn't have to put a 0 in for a placeholder. This synthetic division only works if the divisor is linear, which means the divisor is just an x term. So, to start out, what you do is you bring down the first coefficient, 1. Then you multiply 5 times 1 and write it up here. Then you add negative 8 plus 5, write a 3, negative 3. Then so you're always multiplying diagonally and adding up and down. Then I multiply 5 times negative 3, and I write it right here, which is negative 15. Remember, you add up and down, then you add 17 plus negative 5, and you get 2. And then you multiply diagonally and get 10. Then you add vertically and get 0. So this is a factor. Your resultant is, if this is the remainder, right here, this is the constant, this is the linear term, and this is the coefficient of the quadratic term. I always go left or right to left, work this way. So the answer is x squared minus 3x plus 2, and it doesn't have a remainder. So let's do this one right here. Remember, you bring down the first number, which is a 1. You multiply across diagonally, and then you add vertically. Multiply diagonally, add vertically, multiply diagonally, 14, add vertically. So this one does have a remainder of 5. So this is the constant term, this is the linear term, this is the quadratic term. So it's x squared plus 3x minus 7, remainder 5. Then don't forget, you bring the first number down, multiply diagonally, add vertically, multiply diagonally, add vertically, multiply diagonally, add vertically. This is the remainder. You're left with negative 2x squared plus 9x minus 49. And then the last one, bring down the 1. So you should always try to stop, pause, see if you can do it yourself. 1 times negative 1 is negative 1. Add vertically, multiply diagonally, add vertically, multiply diagonally, you get a 0. This one is a factor. X plus 1 is a factor. My resultant is x squared plus 6x plus 9 is the quotient. Okay, this is the remainder theorem is if the polynomial is divided by x minus a, where a is a constant, then the remainder is p of a. So use synthetic division and the remainder theorem to find p of a. This just means find the remainder. So using, if a is 2, then you're going to do 2. You're going to see if x minus 2 is a factor. So the result is going to be the remainder. So I'm going to set up the long division or the synthetic division on these. Okay, as you can see, I set all these synthetic divisions up. You can check to see how you did. You just want to make sure that you answer this question in proper notation, just like this. So this last one I purposely didn't finish yet because I want to write P of 4 equals the remainder, which is negative 17 is my final answer. Okay, so the volume in cubic feet of a shipping carton is modeled by this. The height is x minus 5 feet. Find linear expressions for the other dimensions. Assume that the length is greater than the width. Use synthetic division. So if you remember the volume of something, of a carton, this is a carton. So we're going to assume that this is a box, a rectangular shape. So I'm going to divide x minus 5 or divide this by x minus 5. So I'm going to use synthetic division. Remember, if x minus 5 is a factor, then 5 is a 0. So I set this up. And I did the synthetic division, so x squared minus x minus 2 is still a factor. So I can factor this out now and do x minus 2 and x minus 1. So these are the other dimensions. So the dimensions are x minus 5, x minus 2, and x minus 1. So this is the height. The length is greater than the width. So that if the length was greater, then it would have to be this value is going to be greater, because x minus 1 is always going to be greater than x minus 2 if x is positive like that. So this is the width. If the width of the carton is 4 feet, what are the other two dimensions? So if 4 equals x minus 2, then x is 6, so that would make the height will be 1, because 6 minus 5 is 1. The width will be 4, and the length will be 5. Feet, feet, feet. Suppose that you use synthetic division to divide a polynomial by x minus 5. What does the last number on the bottom line represent? It represents the remainder. So if the remainder is 0, we know it's a factor.